Good morning, guys. So let's start tomorrow lecture on the topic on the topic bootstrap air cooling system. This is the third one of third type of cooling system used in air refrigeration system. Before that, we are discuss about the evaporative cooling system and cooling system, and they are generally used in aircraft. So let's start bootstrap air cooling system. So bootstrap air cooling system as shown in figure. This one is the bootstrap air cooling system where same arrangement has to be done here as we have to see in air evaporative cooling system which was discussed in the previous lecture. But the main difference in that one and this one is at that one we are use the evaporator, but here we are using the second heat exchanger. Okay, and uh, two new things are joined here. The first one is the second heat exchanger, and second is the secondary compressor to improve the quality of cooling. So let's start. We have to first to take atmospheric air, atmospheric air enter into the duct after the ramming process. This rammed air is again divided into two parts. First is goes into the main compressor where again it is divided into two parts. First one is the combustion chamber and second one is the um, passing through the first heat exchanger. Okay, and here there is a arrangement of passing rammed air from first heat exchanger and second heat exchanger to exchange heat from the air that can be passes from the main compressor. Okay, when the main compressor is passed to the first heat exchanger, it becomes the cool, means the temperature is decreases. At the same time, it again passes to the second compressor, the temperature and pressure again high. Here, some of the air is passes to the cooling turbine, where it is circulating and provide a driver soak and driver mm, force to the air that can be passes to the second uh, heat exchanger. Okay, and ultimately the cool air is passing through the cabin. So let's start what they are saying. This cooling system has two heat exchanger. We all know that about this. Instead of one and a cooling turbine driving a second compressor instead of cooling fans. Okay, the air drained from the main compressor is first cooled by the rammed air in the first heat exchanger, and secondly, the cool air after compression in the second compressor is led to the second heat exchanger where it again cooled by the rammed air before passing through the cooling turbine. This type of cooling system is mostly used in transport type aircraft. Okay, remember, generally this type of system are used in transport type aircraft. So, the temperature entropy diagram for bootstrap air cycle system shown in next slides, and the process here. Okay, this is the process. Just a second. Uh, we just take this for this time. Hmm. So uh, the process 1 to 2, here we are here, this is the 1 and this is the 2. Again we are know that this is the ramming process, means atmospheric air enters into the duct after the ram process. The isentropic ramming of ambient air from pressure P1 and temperature T1 to the pressure P2 and temperature T2. The process 1 to 2 dash represent the actual running process because of internal friction due to irreversibility. It has a पूरा statement you have to easily understand. After that, the process 2 dash 3 represent the isentropic. Here we are here 2 dash and 2 dash to 3 is the compression process by the main compressor. So 2 dash 3 represent the isentropic compression of air in the main compressor, and the process 2 dash 3 dash represent the actual compression of air because of internal friction due to irreversibility. Same reason is going flow out the process. The third one is the process 3-4 represent this one. 3-4. 3-4 is the, sorry, this one is the 3-4. 3-4 is the uh, main compressor, main compressor pressure, where the pressure should be remains constant but the temperature decreases from T3 to T4. And when the process 4 to 5, this will be the work done by the second compressor, where again pressure and temperature goes high, and we are passing this to the second heat exchanger, where ultimately the temperature decreases but pressure remains constant, and ultimately it passes to the turbine, or say passes to the turbine, or say it will be passes to the expansion wall, and ultimately the pressure should be decreases from P6 to P7, and ultimately P7 and P8 is the area where the cabinet plays a role, and ultimately we are find out COP of the system. Okay, so we again know that mass, we have to find out the mass, whatever the mass of the system, by using the formula, refrigerating effect is equal to NA into CPA into T8 minus T7 dash. Okay, so you just find out mass flow rate by multiply 210 into how much tons of refrigeration they are produced, and ultimately find out the mass of the system. Okay, similarly we are required the power required by the refrigeration system. So in this time we have by first we have to find out the work done. Work done by the compressor is denoted by MA into CPA into T3 dash minus T2 dash, and when it is divided by 60 we are getting the power output. So this type of formula are used here. Power output is equal to MA CPA T3 dash minus T2 dash divided by 60. Similarly, COP of the refrigeration system we have already discussed in the previous slide. So this is all about your numerical part, means when you have to find out the COP of the system, you have to calculate first mass flow rate, then ultimately the refrigeration effect, and lastly what is the power required to run the system. Okay, and this is the numerical which we have to discuss here. First one is the, they are say that a bootstrap cooling system of 10 TR capacity is used in an aeroplane. The ambient air temperature and the pressure are 20 degrees Celsius and 0.85 degrees Celsius. This will be the value of ambient air, means P1 and T1. The pressure of air increases from 0.85 bar to 1 bar after the ramming process, means we are getting the value of P2. The pressure of the air discharged from the main compressor. Okay, so you just remember the thing. Just a minute. No? You just remember the thing. This, if you remember this diagram, you all are very much capable to solve the numericals. So, pressure of air discharged from the main compressor. So after main compressor, this one is the 2 dash and 3 dash. 3 is the discharge of main compressor. So we are getting the value of P3. So P3, or say, here you just watch, this P3 is equal to P3 is equal to P3 dash is equal to P4. That's why they are writing here. Uh, P3 is equal to P3 dash is equal to P4 is equal to 3 bar. Okay. And the discharge pressure of air from the auxiliary compressor is 4 bar. Okay. Auxiliary compression means secondary compressor. We talk about the secondary compressor. So the values are P5, P5 dash, and P6 is equal to 4. Okay. Then the isentropic efficiency of the compressor is 80%, while that of turbine is 85%. 50% of enthalpy of air discharged from the main compressor is removed in the first heat exchanger, and 30% of enthalpy of air discharged from the auxiliary compressor is removed in the second heat exchanger using rammed air. Assuming ramming action to be asymptotic and required cabin pressure of 0.9 means this is the condition of uh, this one, this one. So we are getting the value of P7, or say P7 dash, or say P8. The values are given, and 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 the air leave the cabin. That means it will say about the T8. The value of T8 is 20 degrees Celsius. So T8 is equal to 20 degrees Celsius means 293 Kelvin. So what you have to find out, the first one is the power required to operate the system. Secondly, COP of the system. Draw the systematic and temperature entropy diagram of the system. Take gamma is equal to 1.4 and Cp की value आपको 1 kilojoule per kg Kelvin consider करनी है. Okay. Before discuss about this question, one question rises in the mind: कि what is the basic difference between bootstrap air cooling system and and simple air evaporative cooling system? Why we are just replace evaporator with the help of heat exchanger? And secondly, why second type of compressor is introduced into the system? Okay, remember the question, answer me in the YouTube channel. बात समझ में आ गई आपको क्या, कि मैंने आपसे क्वेश्चन पूछा है कि बूट स्ट्रैप एयर रेफ्रिजरेशन सिस्टम में हमने सेकेंड हीट एक्सचेंजर लगाया और साथ में एक ऑक्सिलरी कंप्रेसर या सेकेंड कंप्रेसर भी ऐड किया, जबकि इवोपरेटिव सिस्टम में एक्चुअली हमने केवल इवोपरेटर को ही ऐड किया था. तो अब एक इवोपरेटर को हटा के उसकी जगह पर मैंने कंप्रेसर भी लगाया और सेकेंड टाइप ऑफ हीट एक्सचेंजर भी लगाया. इसकी ज़रूरत क्यों पड़ी? इसका आंसर आपको मुझे देना है. ठीक है, अब वापस आते हैं न्यूमेरिकल में. तो अब जैसे आपने ये न्यूमेरिकल को समझा तो आपको ये आइडेंटिफाई हो गया होगा कि पूरे के पूरे सिस्टम में आपको बेसिक से स्टार्ट करना है। बेसिक का मतलब क्या होगा, T1, T2, T3, T4, T5, T6, T7, T8। सिमिलरली T1, T2, T3, T4, T5, T6, T7, T8 सब कुछ आपको फाइंड आउट करना है। आप ये देखो कि मेरे ख्याल से T1, T2, T3, T4, T5, T5, T6, T7 और T8 की वैल्यू आपको दे के रखी है। मतलब प्रेशर के साथ आप कंप्लीटली फुलफिल। अब आते हैं टेम्परेचर की बारी। तो आपके पास T1 टेम्परेचर दे के रखा है और T2 का पता नहीं है। तो मेरे ख्याल से T1 और T2 का विथ रिस्पेक्ट टू प्रेशर आपको रिलेशन आप फाइंड आउट है, मतलब पता है। इसलिए आप ये रिलेशन के साथ, ये 1 होगा ये 2 होगा, आप ये रिलेशन के साथ अल्टीमेटली T2 की वैल्यू फाइंड आउट कर लोगे। चलिए, उसके बाद क्या T3 है? नहीं है। तो फिर से लॉजिक वही आया कि T3 की वैल्यू आप निकाल लोगे, देन T4 की वैल्यू, देन T5 की वैल्यू, T6 की वैल्यू, T7 की वैल्यू और T8 की वैल्यू आपके पास दी है। अब जब आप ये वैल्यूज निकालोगे तो यू हैव टू फाइंड आउट द एक्चुअल सिस्टम एनालिसिस। मीन्स आपने देखा होगा कि यहाँ पे आपको नहीं, जनरली कम रैम्ड एयर में जरूरत नहीं पड़ती है। अब यहाँ पे आपको T3 की वैल्यू निकालनी है, T5 डैश की वैल्यू निकालनी है और T7 डैश की वैल्यू निकालनी है। T3 डैश, T5 डैश, T7 डैश। तो इस जगह पे अब आपको इफिशिएंसी वर्ड का यूज़ करना पड़ेगा। तो आपको जब याद होगा कि इफिशिएंसी के टर्म्स में आप क्या करते थे, तो एक्चुअल सॉरी आइडियल अपॉन एक्चुअल लेते थे। तो आपके पास एफिशिएंसी है, आपके पास T3 की वैल्यू है, आपके पास T2 की वैल्यू है, तो आप T3 डैश की वैल्यू फाइंड आउट कर सकते हैं। इसी तरीके से आपको T4 डैश की वैल्यू फाइंड आउट करना है। नहीं, आई थिंक T4 की डैश नहीं है, T5 डैश है। तो T5 डैश की वैल्यू आप फाइंड आउट कर लेंगे सेम एफिशिएंसी के फॉर्मूले से। अब इसी तरीके से अब आपको निकालना है T7 डैश। ये देखिए, आपके पास T6 की वैल्यू है, T7 की वैल्यू है, ईटा की वैल्यू दीजिए तो आप इससे T7 डैश की वैल्यू फाइंड आउट करेंगे। चलिए, जब आप सारी वैल्यूज आपने फाइंड आउट कर ली, यहाँ पे सारी वैल्यूज फाइंड आउट कर ली, तो अब आपको वो क्या पूछ रहे हैं, तो वो बोल रहे हैं पावर एंड COP। ठीक है, तो पावर और COP फाइंड आउट करने के लिए आपको उसने पहले स्टेटमेंट दिया था कि आपको सबसे पहले मास फ्लो रेट निकालना है। तो मास फ्लो रेट कितना होगा, तो मास फ्लो रेट आपके RE के फॉर्मूले से जनरेट होगा। तो RE मतलब 210 इंटू 10 टर्न्स लिखा हुआ है, डिवाइडेड बाई CP की वैल्यू देकर रखी है। T8 और T7 डैश आपके पास गिवन है, जिससे आप मास फ्लो रेट निकाल लोगे। अब मास फ्लो रेट निकालने के बाद पावर रिक्वायर्ड कितनी है, तो पावर इज इक्वल टू CPA T3 डैश माइनस T2 डिवाइडेड बाई 60। इसके बेसिस पे आपका पावर कितना रिक्वायर्ड है वो आप फाइंड आउट कर लोगे। अल्टीमेटली इससे आप COP ऑफ द सिस्टम निकाल सकते हैं। ये हो गया आपका बूट स्ट्रैप कूलिंग सिस्टम, एयर कूलिंग सिस्टम। नेक्स्ट लेक्चर में बूट स्ट्रैप एयर इवोपरेटिव कूलिंग सिस्टम की तरह। आज के लिए इतना काफ़ी है। थैंक यू वेरी मच।